All right, everybody, welcome back. Let's do a deep dive into something pretty fascinating today, cybersecurity.
Definitely interesting stuff.
Yeah, we're always hearing about the latest hacks and vulnerabilities.
It feels like a never-ending battle.
It really does. But what's got me particularly interested today is how Google is trying to change the game entirely with Android security.
Oh, how so?
Instead of just playing catch-up with patches and fixes,
Right.
they're trying to prevent these vulnerabilities from existing in the first place.
Now that's an intriguing concept. What's their strategy?
Well, we've got some excerpts here from this article. It's called Paste in Text. A little dry, I know.
Yeah, catchy.
Right. But the content is actually really cool. So basically, they're really diving deep into something called memory-safe languages. Have you heard of these?
Absolutely. It's a pretty big deal in the cybersecurity world right now. Think of it like this traditional programming languages. They sometimes have these inherent weaknesses that can be exploited.
Oh, like loopholes in the code itself.
Exactly. But these memory-safe languages, like Rust, for example, they're designed from the ground up to eliminate those loopholes. It's like the language itself prevents those vulnerabilities from even being written in the first place.
Okay, that's
Yeah.
pretty clever. So by using these memory-safe languages for Android, Google's essentially trying to create a system that's fundamentally more secure.
You got it.
Well, and it looks like it's actually working. This article had this crazy stat. Since they started focusing on these languages, memory-related vulnerabilities in Android have plummeted.
Oh, wow. Yeah, I read about that. It's a significant drop.
Yeah, from like 76% down to just 24% in 6 years. I mean, that's huge.
It really highlights the potential impact this approach can have. If you can build security into the foundation of the code itself, it can drastically reduce the attack surface for hackers.
Right. And I think that's something most people don't realize, how much of our digital lives depend on the security of code.
Absolutely. It's the invisible backbone of everything we do online.
So this is much bigger than just some technical jargon. We're talking about a fundamental shift in how software is built, right?
You could say that it's a move from reactive security, you know, patching holes as they're found, to a proactive, preventative approach.
I like the sound of that. But I have to imagine it's not as simple as just flipping a switch, right?
Yeah.
Rewriting an entire operating system like Android with these new languages. That's got to be a massive undertaking.
Oh, absolutely. And that's where things get really interesting. How do you implement a change like this on such a massive scale?
Yeah, that's a good point. There are already so many different parts and pieces to Android as it is.
Exactly. And the article touches on that it's not about scrapping everything and starting over. It's about this concept of interoperability, making sure that these different languages, Rust, C, Kotlin, can all work together smoothly.
So they're kind of building bridges between these different coding languages.
That's a great way to put it. It's like creating a multilingual environment where everything can communicate and function seamlessly.
Fascinating. So even if they aren't rewriting everything overnight, it seems like this move to memory-safe languages is a really big deal for the future of, well, everything.
Oh, for sure. And, it raises some pretty big questions about the future of cybersecurity as a whole. I mean, could this lead to a world where software is inherently more secure right from the start?
Right. And if so, what does that mean for the hackers and the security researchers? I mean,
Hmm.
where do they fit into this new world? And what about the trade-offs?
Exactly. Are there downsides to this approach? These are all things worth digging into.
Okay, so let's get into it. So we're talking about this big push for more secure code, but Google's not stopping there, are they?
Definitely not. This memory-safe language thing, it's a huge step, but it's not the whole picture.
Right, like they're still got to deal with all the other potential weak points, right?
Absolutely. The article actually highlighted this partnership they have with ARM.
ARM, like the company that makes those chips.
Yeah. Exactly. They're a major player in the chip design world, and the collaboration is specifically focused on finding vulnerabilities in GPU software.
Okay, hold up. Time for a quick tech breakdown. What exactly is GPU software and why should I care about it?
Sure, no problem. It's all about the visuals, really. GPU stands for Graphics Processing Unit. It's a specialized chip that handles everything you see on your phone.
So like making sure my apps look all nice and pretty.
Exactly. Display, video playback, gaming graphics, that's all the GPU.
Got it. But like any software, I guess it can have its own security flaws, huh?
Exactly. It's another potential entry point for hackers. So even with these memory-safe languages making the core system more robust, they still need to address those other areas.
So it's like they're reinforcing the whole fortress, not just the front gate.
A perfect analogy, and it underscores this important point. Cybersecurity is never done. It's not a one-time fix.
It's like you can't just install an antivirus and call it a day.
Right. It's an ongoing process of identifying weaknesses, patching them up, and then anticipating the next wave of threats.
Constantly staying one step ahead of the bad guys. But all this focus on security got me thinking, are there any potential downsides to this secure by design approach?
That's a great question and one that often gets overlooked. While the benefits of building in security from the ground up are huge, there can be trade-offs.
Okay, let's talk about those trade-offs. What kind of downsides are we talking about here?
Well, one thing that comes to mind is the potential impact on development speed.
So this whole secure by design thing could actually slow down how fast they can make new software.
It's definitely a possibility. I mean, think about it. If you were building a house and you had to stop and reinforce every wall every step of the way.
Yeah, it would definitely take a lot longer to build a house that way.
Exactly. And it's not just about speed either. There's also the potential impact on innovation.
Oh, that's interesting. How could focusing on security actually make things less innovative?
Well, if developers are constantly worried about introducing security risks, they might be less likely to take chances on new ideas.
So it's kind of like a balancing act.
Yeah,
You want things to be secure, but you don't want to stifle creativity and progress.
exactly. It's about finding that sweet spot, that balance between security innovation and user experience. And it's not always easy.
Sounds like a tough challenge.
It is. But that's what makes this field so interesting. It's constantly evolving.
Well, this deep dive has definitely given me a lot to think about. I never realized how much goes into building a secure digital world.
Yeah, it's something most of us probably take for granted, but there's a lot happening behind the scenes.
It really feels like this whole secure by design thing is just the tip of the iceberg. Makes you wonder what other changes are coming down the line.
For sure. It's an exciting time to be paying attention to this stuff.
It really is. And, maybe some of our listeners will be inspired to get involved in building a more secure digital future.
I hope so. We could always use more bright minds working on these challenges.
Couldn't agree more. Well, we've covered a lot of ground today, from memory-safe languages to the potential trade-offs of secure design. It's been quite a journey.
It has. A lot to digest, but definitely important stuff.
Absolutely. So to wrap things up, a huge thank you to you for sharing your expertise with us today.
My pleasure. Always happy to geek out about cybersecurity.
And to all our listeners, thanks for joining us on this deep dive into Google's Secure by Design mission for Android. Until next time, stay curious, stay safe, and we'll catch you on the next deep dive.